Imagine you are Pac-Man. One day, you go for a walk. You grab your two-dimensional wallet, leave your two-dimensional house, and head off in some direction. After a moment's walking, you spot a wallet. It's yours. Sure enough, your pockets are empty, you put your wallet away and continue. See, Pac-Man is accustomed to finding things he's dropped without ever turning around. Because when Pac-Man goes up through the top of his screen, he comes in through the bottom. When he moves out the right, he comes in through the left. What is this strange surface? Well, from Pac-Man's point of view, the top and bottom are joined together. So are the right and left. So as you can see at the top, Pac-Man lives on the surface of a donut. But why a donut? Why not some other two-dimensional surface, like that of a sphere or a two-hole donut? This begs the question, which two-dimensional surfaces can actually exist for Pac-Man to live on? This is a question in a branch of mathematics called topology, and it was answered about 100 years ago. What about a three-dimensional Pac-Man? This is someone much like me. Likes cherries, hates ghosts, but most importantly, lives in 3 dimensions. But maybe the three-dimensional world I live in has the property that when I walk out through that wall, I come in through there. Or if I look out the back of the room, I see the back of my head. Or if I look up, I'm just thankful I'm not wearing a kilt. The question of which three-dimensional surfaces can exist was answered in 2003, and its solution was worth $1 million. Why stop at 3? What about 4 dimensions? So here the 4th dimension is just another direction independent to the first 3. Which 4-dimensional surfaces can exist? Well, we don't actually know. This is one of the major open problems in topology, and it's the one I'm hoping to put a dent in my research. The approach is to study symmetries of 2-dimensional surfaces. So a symmetry is something I can do while you're looking away that you can't notice. For example, if I had a glass of wine here, if I rotate it, that's a symmetry. If I drink it, that's not. The entire group of symmetries of a 2-dimensional surface has a structure on it, much in the same way that the whole numbers have addition. Studying this structure, perhaps surprisingly, can help us understand 4-dimensional surfaces. Now, why should you care about something abstract like this? Topology is part of the gigantic machine that starts at pure mathematics and ends at new technology and understanding. The topological foundations laid down 100 years ago are being used today in quantum computing and even featured in last year's Nobel Prize in chemistry. Why do I care? Pure mathematics, and especially topology, is one of the most beautiful and compelling things anyone can ever experience. And that is enough reason for me. Thank you.